In this video, we're going to go over some additional aromatic compound terminology. So we'll start off with some positional terminology. We have the ortho, meta, and para notations. So ortho represents substituents that are right next to each other. For example, over here, we could call this 1,2-dichlorobenzene, or you could call it ortho dichlorobenzene, which means the same thing, 1,2, because the chlorines are right next to each other. The meta notation, or M, the substituents are separated by one carbon. So here we have 1,3-dichlorobenzene. You can call this meta or M dichlorobenzene because they're separated by one carbon there. And then when the substituents are at opposite ends of the benzene ring, like you see over here, opposite ends, you can call it para or P. So here you can call it 1,4-dichlorobenzene or para dichlorobenzene. Notice you still do have to put the di, even though you're only putting one little prefix there. You still have to put dichloro because there's two chlorines. So this really works when you have two substituents on the benzene ring. So we can go ahead and try to name these compounds using the regular notation and the ortho, meta, and para notation. I'll start with regular notation that you're used to. So here we have 1, 2. So 1, 2, dimethyl benzene. Here we have 1, 2, 3. So 1, 3 dimethyl benzene, and here we have 1, 2, 3, 4 1, 4 dimethyl benzene. So here where they're separated by, where they're right next to each other, remember we can call that ortho. So this is going to be ortho, or you could just put O, ortho dimethyl benzene. Here they're separated by one carbon, so that's meta. So meta or M dimethyl benzene. And then here they're opposite of each other on opposite sides of the benzene ring, so that's para or P. So para dimethyl benzene. You should also be able to draw from the name that's provided. So here you'll notice that we have the O-ethyl methyl benzene. So let's go ahead and draw our benzene ring first as our parent chain. And I can just draw it with a circle like that. O means ortho, so they're right next to each other. So I'll do my ethyl over here. So 1, 2, and then my methyl over here. So this is ortho because they're on carbon 1 and 2 right next to each other. And again, that O means ortho. Next, we're going to go and take a look at what happens when benzene is not the parent chain, but instead is a substituent. So if benzene is connected to a parent chain that has 6 carbons or more, or if you have a chain that has double bonds, or that's heavily substituted, or that has higher priority groups like alcohols, amines, or the amides, esters, anything in the priority list that we've seen, if there's a parent chain that has higher priority things, then generally your benzene will no longer be your parent chain and will become one of these substituents. So when you have a lot of substituents on a chain, when your chain is 6 carbons or more, when you have multiple bonds or higher priority groups, then you're going to have it as a substituent. When benzene is a substituent, it is called phenyl. And when it's a substituent, you treat it like a regular alkyl substituent in terms of numbering based on the alphabetical order and priorities. So here we have the example of, we have a name given to us, we have to draw it, 1-chloro-5-phenyl pentane. So based on this, we're going to have a parent chain that's pentane, 5 carbons, 1, 2, 3, 4, 5. On carbon number 1, we'll have a chlorine. So that's carbon number 1, then 2, then 3, then 4, then 5. On carbon number 5, we have phenyl, which basically means you're connecting that to a benzene ring. And so, yes, I know that we have a 5 carbon parent chain. It's less than 6, but it's probably because it's heavily substituted. It has a lot of substituents on it. We have the chlorine and we have the phenyl. So that's why we gave it this name over here, with the parent chain being the pentane as opposed to the benzene. Next, we'll try to name this one here. So you'll notice that we have a lot of substituents over here. So there's a lot of substituents put on this chain here. We have a chlorine, we have a methyl, and because we have a lot of substituents here, we're likely going to call this a phenyl as opposed to make this the parent chain. So our parent chain is going to be here, and this is going to be one of our substituents. We can start numbering in whatever direction gives us the either alphabetical order or first point of difference. Now, what you'll notice is that in this case here, it's probably better to start numbering from this carbon. It's carbon number 1 because chlorine comes first, and it also gives us our lowest substituent numbers. If we started carbon number 1 here, then our first substituent would be a carbon number 2, and that would not be the lowest substituent numbers either. So 1, 2, 3, 4. So let's go ahead and name this. So we have a 1-chloro, 3-phenyl. So again, listing in alphabetical order there. And then since it's 4 carbons with only single bonds in it, butane. Okay. Now, this is our next problem. We have to name these. Notice that we have a double bond here. So I don't think we're going to be using the benzene as our parent chain since we have a chain with a double bond. So I'm going to find the longest chain that contains that double bond, and it seems to be this chain over here. So we want to start counting from the area that minimizes the double bond. So carbon number 1, 2, 3, 4, 5, 6, 7. So that means on carbon number 3, we have a phenyl and a methyl. The methyl would be listed first because alphabetical order. So 3-methyl, 3-phenyl, and then it's a 7-carbon structure with a double bonds on carbon number 1, so heptene. Here's a nice straightforward one, 2-phenyl octane. We can tell that's a chain that's bigger than 6, greater than 6 carbons. So there's 8 carbons in that one. So we'll do 1, 2, 3, 4, 5, 6, 7, 8. Doesn't really matter where we start counting from. We'll make this end carbon number 1, this carbon number 2, and we'll have a benzene on our carbon number 2. Like that. And so here we did some examples of drawing of compounds, drawing or naming when benzene is no longer the main chain, but rather a substituent. We saw it's the case when you have chains that contain multiple bonds, like double bonds or triple bonds, when you have a lot of substitutions in the chain, with this word I have a hard time pronouncing, or if you have higher priority groups in the chain, like if you have alcohols, amines, amides, esters, aldehyde, ketone, carboxylic acids, or any of those higher priority ones that we've seen in our priority list, then we're going to count the benzene as a substituent, and call it phenyl as opposed to a main parent chain. We also saw the ortho, meta, and para notation when it comes to benzene naming. So be familiar with that because you can be presented with those names or you can be told to name using that system as well.